When it comes to Chapter 5, now that we are covering quantitative data, it may be useful to look at one set of quantitative data and graph a histogram, but oftentimes what we want to do is compare two or more pieces of quantitative data that we've collected. And so we have to have a couple other techniques that we want to use. So here's the homework for Chapter 5. About 10 questions to practice these skills. Remember, draw a picture if you want to get full credit. Likewise, there is a quiz that will be up on Schoology, as well as our second free response question that we'll be attempting for this class. So the objectives that we have for Chapter 5 are to summarize data using box plots, re-express data for comparing between groups. So emphasis on a box plot. So with a box plot, or some of you might see it called a box and whisker plot, is a graphical display of the 5-number summary. As we saw in the last chapter, the 5-number summary is the lowest value or the min, Q1, Q2, which is the median, Q3, and the highest value, which is the max. Box plots are useful when comparing groups of data. Also, box plots are particularly good at pointing out outliers. Now, I want you to think about, as we discuss box plots, why would we use these with mean and IQR and our 5-number summary as opposed to mean and standard deviation? So a box plot is drawn either above or to the side, a scale for the data. So if you're putting your scale of your data, it's either horizontal or it's vertical, but no matter what, we are always labeling what we are graphing. And what we do is we place the minimum, Q1, the median, Q3, and the maximum values in this type of order, with the focus being the IQR, and the median for a box plot is our middle 50% of the data. So in order to draw a box plot for the number of hours spent on a computer each day, let's say I went and asked each one of the teachers that work here how long they spent on a computer over the summer. The first thing that we need to do is order the data. So if you don't know how to order the data, then it becomes quite difficult to create your 5-number summary. So I'm just going to hop over to my graphing calculator, and I'm going to make a new spreadsheet. So if I hit new, I'm going to say add a list or spreadsheet, and we're just going to call this hours. Now if I hit 2, 6, 3, 4, 2, 1, 2, 0, 1, 3, 6, 3. If I want to organize this, if I select, go all the way up to the column, and I hit menu, I can go to actions, sort the data in ascending order. Now, if I look at my data, I can see I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces of data. Once it's ordered, I can use a shortcut and use my calculator. Let's make sure that I'm in the cell that I want. I use my calculator and go to Statistics, Stat Calculations, and then one variable statistics. I hit enter and then enter again, and I just scroll down a little to the bottom. I can see that my minimum value is 0. Q1 is 1.5. The median is 2.5. Q3 is 3.5. And the maximum value is 6. Now, how do we get this? If I just zoom out back onto the notes, I can see that I have 12 numbers. So I have 2 blocks of 6. To find the median of those middle terms, remember, to find the middle number, we do the number of terms plus 1 over 2. So that would be the 6.5 spot. So I need to average the 6th and 7th number to find the median. Likewise, in my bottom quartile, my bottom 50%, to find Q1, I find the halfway between, I have 6, so 7 plus 1 would be between 3 and 4. So halfway between 1 and 2 is 1.5. My lowest value is 0, my highest value is 6, and I can do the same thing for Q3. Whichever way you're choosing to identify the 5-number summary, it's up to you. Once we have the 5-number summary, we are going to put this on our scale. So our numbers, which would be in hours, would be from 0 to 6. We place our median at 2.5. We place our Q1 at 1.5. We put our Q3, Q1, Q3, and then for now, we are going to say our max value is there, and our min value obviously is at 0. For these small values, we're not worried about where we place the whiskers, although there is a specific way I want you to be able to do this. When we are looking at a box and whisker plot, the sections of the box plot display the data distribution. Each section represents 25% of the data. If the median is near the center of the box plot, the data is relatively evenly distributed. The min and max values are equidistant from the mean. In our picture below, we can obviously tell that the median is not in the middle of our box plot. And this goes to symmetry. So the symmetry of a box plot is an indication of the symmetry, or lack thereof, of symmetry in the distribution of the data. If the median is near the center of the box plot, the data is relatively evenly distributed. Then you would use mean and standard deviation. If the median is not in the center of the box, and let's say the median is to the left of the center, then the data is positively skewed. And if we remember what positively skewed, that just meant right skewed. If the median is on the right-hand side, the data is negatively skewed or left skewed. So this helps us if we are looking at all of our data at a glance. This simple box plot can tell you a lot about your data set. So if we're looking to compare distributions, and comparing distributions reveals useful information about the data. So to the right is a histogram of the average wind speed for every day in 1989 at some undisclosed location. Okay, so if we look at this, the beautiful thing about this chart is we have our axes labeled, we have our 5-number summary. And when you're writing this up, we are going to always remember our SOCs. So our shape, outliers, center, and spread. Shape is humps. If we have any outliers, which looks like, is this an outlier past 8? Our center, we would use the median measure, and for our spread, we would report out IQR and potentially along with range. So let's say it. The distribution is unimodal with the mode between 1 and 1.5. The data is significantly positively skewed, or we would say right skewed. How do we remember that? If we draw our picture, the whale's tail is where the skew is. So the whale's tail is on the right, so it's right skewed or positively skewed. There is a gap in the data from 6.5 to 8.5 miles per hour. The value of 8.67 may be an outlier. And so we need to figure out a way of telling if that's an outlier or not. The median daily wind speed is 1.9 miles per hour, and the IQR is 1.78. And again, we can find IQR by subtracting Q3 from Q1. So my question to you is there more we can determine? So with the 5-number summary of the distribution, it reports out the median, the quartiles, and the extremes. As we've seen, we have our max, our Q3, our median, our Q1, and our min. But what else do we need? So let's go about how do you construct a box plot? Because we have our histogram. Again, we have our histogram. We see the distribution. How can we go about constructing a box plot? So what we do is we draw a single vertical or horizontal line. We're going to do horizontal in this case, spanning the range of our data. We are going to draw short horizontal lines for Q1, Q3, and the median. So utilizing the data on the left, Q1 is 1.15. So 1.15 would be roughly here. Our median is at 1.9, which is at roughly here. Q3 is at 2.93, which is roughly right at 3. And then we have our minimum value. Well, let's draw our box. There we have our box. Next up, find IQR. So in this case, it would be 2.93 minus 1.15, which gives us our 1.78. This is how we calculate the fences, the whisker parts for our box and whisker plot. So we take the upper fence is 1.5 times our IQR. That will give us the upper quartile. Sorry, it's above Q3. So if we do 2.93 plus 1.5 times 1.78, we get roughly 5.6. Likewise, if we find the lower fence, it would be 1.5 IQRs below Q1. And so if we subtract that, we get a negative value. Now note, you can't have a negative wind speed, so the lowest value that we can be is 0, and that gives us our 2 fences. Note, the fences only help with constructing the box plot and should not appear in the final display. So use the fences to grow the whiskers. Draw lines from the ends of the box up and down to the most extreme values found within the fences. If a data value falls outside one of the fences, we do not connect it with a whisker. So if we have our 2 fences and we have our box, this goes down to 0, we can start to see that that value of 8.67 falls outside of our box and whisker plot. This is when we add our outliers. So outliers are by displaying any data values beyond the fences with a special symbol. Oftentimes we just use an asterisk, but if you want to use like a smiley face or something else, as long as you know what that means, that's why we include it. You can use a different symbol for far outliers that are more than 3 IQRs from the quartiles. So again, we indicate special things that we need to make note of when we're talking about our data. Now we have a way to quantitatively determine what values are outliers. When we use median as our measure of central tendency, we use IQR to identify outliers. For data values below Q1, so if we do 1.5 IQRs below Q1, or subtract it, those could be considered outliers. Likewise, if we're looking 1.5 IQRs past Q3, those also could be considered outliers. So with outliers, to determine whether a data value can be considered an outlier, we need to locate Q1 and Q3, find the IQR, compute 1.5 IQRs, compute Q1 minus that value and Q3 plus that value, and then we're going to compare the data values that we have with those ranges. So identify any outliers. If the number X is lower than your lower whisker or above your upper whisker, which is what those 2 values mean, then consider it to be an outlier. Just a quick aside. If you're wondering why we chose 1.5 as our range, honestly, when statisticians were coming up with this, I'll just say this. Statisticians were coming up with this. They said 1 is not enough and 2 IQRs is too much. And so what they did was they split the difference. And they're like, do you know what? If 1's not enough and 2 is too much, why don't we call 1.5 IQRs how we are going to come up with our box and whisker plot. Fun story. So if we're given a data set, is the value 33 an outlier? So I'm going to, again, hop over to my computer. We are going to hit the home button. We're going to make a new document. We are not going to save changes. We're going to add a list or spreadsheet. and we're going to type this in as data, we have the numbers 5, 6, 14, 15, 15, 18, 19, 21, 33. 1, 2, 3, 4, 5, 6, 7, 8, 9. Got 9 values. First thing that we need to do, if we have 9 values, the median is halfway in between. So 1, 2, 3, 4, 5. 15 is our median. Likewise, we see that in our picture. If we want to find Q1, it's the halfway point of the lower values. So we look at not including the median, the bottom 4, and halfway between 10 and 14 is 12. Halfway between 19 and 21 is 20. So that gives you Q1 and Q3. If you are on your calculator, we would simply, again, hit Menu, Statistics, Stat Calculations, one variable statistics, hit Enter again, and you can see Q1, Q2, median, max, min. So to keep moving, once we have calculated Q1 and Q3, we calculate the IQR, which is 20 minus 12. Next, we will calculate 1.5 IQRs. So 1.5 times 8 is 12. Then we take Q1 minus 1.5 IQR, or 12 minus 12, which is 0. So there's no outliers below that. And then to look at the upper fence, we would take 20 plus 12, which was our 1.5 IQR, and we get 32. And we can clearly see that 33 is above the value 32. So to answer the question, is 33 an outlier? Yep or do. This observation is clearly above our value. Next, if we compare the histogram and box plot to go back to our daily wind speeds, it's easy to see what each brings to the table. So when we're looking at a histogram, it shows us the overall distribution. When we're looking at a box and whisker plot, we can see where the data is concentrated as well as possible outliers. So both bring something unique to the visualization. The vast majority of time in data analysis is by comparing groups. So with histograms, note, we compare the shapes, the centers, and the spreads of the two distributions. So what does this comparison of graphical displays tell you? If we are looking at the wind speeds in the spring-summer in comparison to the fall-winter, we can see that spring-summer is unimodal, is right-skewed, has a mode of the hump that's happening at a relatively low value, probably about between 0.5 and 1, versus fall-winter is unimodal and still right-skewed, but the mode appears to be between 2 and 2.5, and additionally fall and winter shows you some outliers. This is why it's so important when we describe the shape, the center, and the spread, as now we can start using comparison words to distinguish between two distributions. Well, what happens when you want to compare multiple distributions? It doesn't become easy. It's not as easy to just look at a lot of histograms, which is why at a glance, we can look at these box plots. So box plots are simple, but provide enough information for comparing between groups, hiding the details while displaying the overall summary information. If we plot them side by side for groups or categories, we can compare those. So if you're looking at this, you can clearly see as January moves into June that the wind speeds die down, although we have some outliers. And then as summer turns to fall, the wind speeds start picking up. Again, if we look at this maximum liver function based off of a medical treatment, what we want to compare is what is revealed by these comparisons. So ALAT versus ALK-PH or ASAT or Biltot. If we're looking at drug A versus drug B, we can see the overall range of maximum liver functions based off of treatment A or treatment B, as well as any significant outliers. So if there are any clear outliers and you are reporting the mean and standard deviation, again, if you're reporting mean and standard deviation, so you're saying it's symmetrical, you need to report the data with the outliers present and with the outliers removed. Then discuss the differences found. Because mean and standard deviation are susceptible to outliers, that's why we need to omit them. Quick note, the median and IQR are not likely to be affected by outliers, so we say they're resistant to change. Do not ignore outliers, though. An extreme outlier may be a mistake, but it also might reveal something important. Investigate outliers and report them. We do not, in this class, simply throw outliers out. So if you want to, and you have a TI-84, enter the following data. The calculator is smart enough to arrange them in order, but if not, you can. And ensure that all your plots are off. If we are to make a new list on our TI Nspire, so if we are to make the same new list, I would like to show you how to make a box plot. So we have 0, 1, 2, 1, 3, 2, 2, 4, 6, 3, 6. So once you have your data typed in, let's hit Control Doc, and we're going to make a data and statistics graph. On the x-axis, for our case, we're going to pick our variable. And now, if we go to Menu and Plot Type, we now have the option of giving a box plot. If you want to make it vertical, you can simply just switch the vertical nature of it. And you can see as we hover over, we have our minimum value, we have Q1, we have our median, Q3, and our maximum value. Interestingly enough, you do have the option when you have a box plot on this calculator to extend the plot whiskers to the max and min values. Although I do not suggest you do that, it's always worth noting that you are showing box plot outliers. Last little bit of information for chapter 5 with time plots. Often we are interested in how the data behave over time. In these cases, we construct time plots. The time variable is plotted along the horizontal axis, and time is by nature quantitative and continuous, so you always have to keep that in mind. But be very, very, very cautious about extrapolating beyond the data. You do not know that trends will continue past the time recorded. So that's why we always do this analysis and analyze what we've seen, but we never try to extrapolate past time especially. When the data are seriously skewed, it can be hard to summarize them with center and spread, and hard to determine whether the most extreme values are outliers or just part of a stretched out tail. So we will deal with re-expressing data at the end of this course, and actually we're going to see it in chapter 10. So if you are interested in messing with these extremely skewed pieces of data, we will answer those. But one way to make a skewed distribution more symmetric is to re-express or transform the data by applying a simple function. I would say AP loves the logarithmic function. So note how skewness changed or is reduced from the raw data to the transformed data, where we have this skewed data that if we apply the log function onto annual compensation, we see that this skewness now becomes much more symmetric and unimodal. We will, if we have time, we will do this lab. If not, that's the end of chapter 5. We've got homework, we've got free response question, we have a quiz. Thank you for your attention, Falcons. I will see you in the next one.